Today we're going to talk about how to solve absolute value equations. And as the name suggests, absolute value equations have an absolute value inside the equation with one term or more than one term in it. And if you remember, absolute value is always represented by these bars. These are not ones, these are bars. So this equation reads the absolute value of 2d plus 7 equals 11. And our goal is to solve for this variable. Now when we're solving for absolute value equations, you're actually going to take the original equation and write two different, similar, but different equations to solve. And the reason for that is you can have two answers when you're finding the absolute value. If you remember, the absolute value of 10 is 10. And the absolute value of negative 10 is also 10. The absolute value of 5 is 5. The absolute value of negative 5 is 5. So you could have two potential answers in absolute value. Because of that, we're going to write two equations from the original equation, and then we're going to solve both equations. So in each of these absolute value equations, you're going to have the possibility of getting two answers. So let's take a look at number one. Again, I have the absolute value of 2d plus 7 equals 11. The first equation you're going to write is you're just going to completely copy this original equation, term for term, except you're just going to leave out the absolute value bars. So you're going to have 2d plus 7 equals 11. That's the first equation that we're going to end up solving. Now the second equation you're going to write is you're going to take the original equation, and then on the side where there is no absolute value, you're going to negate that side. If it's negative, you're going to make it positive. If it's positive, you're going to make it negative. You don't do anything to the side that has the absolute value terms are. You will drop the absolute value bars off though. So our second equation is going to be 2d plus 7 equals negative 11. Again, the only difference between these two equations is that in this first equation we've copied it term for term. In the second equation, the side that's not the absolute value we have negated. So this is now negative 11. And after you've written your two equations, you're just going to solve each equation. So I'm going to solve this one for d. I'll subtract 7. Divide by 2. And I get 2. So I get d equals 2. This one I'm going to solve for d, so I'm going to subtract 7 again. When I do that, I get 2d equals negative 18. Divide by 2, I get negative 9. Now both of these are potential answers for this equation. Both could work, one could work, or neither of them could work. So in absolute value equations, it's very important that you always check your answers. So you're going to plug both of these answers back into the original equation with the absolute value bars still intact. So I'm going to plug 2 in. Instead of being 2d, I'm going to have 2 times 2. Two times 2, we know is 4. 4 plus 7 is 11. So on the left side we have the absolute value of 11. On the right side we have 11. So does the absolute value of 11 equal 11? Absolutely it does. So since this is true, this checks, and 2 is an answer. We go to 2, or our second equation that we wrote. We got negative 9. So let's plug that in to our original equation. So now we have 2 times negative 9 plus 7 equals 11. And again, when you're plugging these into check, you go to the original equation with the absolute value bars. 2 times negative 9 is negative 18. Negative 18 plus 7 is negative 11. Is the absolute value of negative 11 11? Absolutely it is. So this is true, which means this answer also works. So 2 is an answer, and negative 9 is an answer for question number 1. Now let's look at question number 2. This one is a little bit different because I don't just have the absolute value of some terms on the left side. In our original one on the left side of the equation, we just had the absolute value of 2d plus 7. In this question, I have 4 times the absolute value of t plus 9 minus 5 equals 19. So I'm doing some operations besides just the absolute value. So before we write our 2 equations, we have to do something else. We want to isolate the absolute value term on the left side. So anything that's not inside the absolute value, we want to move to the other side. And we do that just like we do with a normal equation. If you're subtracting something, you add it. If you're dividing something, you multiply it, etc. So since I am subtracting 5, I want to move that to this side, we just add it. So now I have 4 times the absolute value of t plus 9 equals 24. I still have the 4 outside the absolute value. I want to move that to the other side. So since I'm multiplying, I'll just divide. So the absolute value of t plus 9 equals 6. So I've gone from this original equation to this equation. Now I can write my 2 equations. I'm going to do that just like we did in our first equation. I'm actually going to write all my work over here since I'm running out of room over here. So the first equation you write is just going to be an exact copy of this equation, just without the absolute value bars. So you're going to have t plus 9 equals 6. The second equation you're going to write, you're going to negate the side of the equation that does not have the absolute value. So instead of being t plus 9 equals a positive 6, you're going to have t plus 9 equals negative 6. These are my 2 equations that I'm going to solve. I'm going to solve for t. I'll subtract 9. When I do that, I get t equals negative 3. I'm going to subtract 9 here, and I get t equals negative 15. Again, both of those have the potential to be an answer to question number 2. We want to check those answers to see if they work. So what we're going to do, we're going to plug these in to our original equation. I'm going to plug negative 3 in for t. So I'm going to have 4 times negative 3 plus 9 minus 5 equals 19. And I know a lot of you are thinking right now, I don't want to waste my time and check my answers. In absolute value equations, a lot of times you're going to get extraneous solutions, or what I mean by that are solutions that do not work. So you always want to check. So negative 3 plus 9 is 6. The absolute value of 6 is 6. Four times 6 is 24. We get 24 minus 5 is 19. 24 minus 5 is 19, so we get 19 equals 19 down here. So since both sides are equal, this checks out, and that is a solution to question number 2. Let's check negative 15 now. I'm going to plug negative 15 into this equation. So I have 4 times negative 15 plus 9 minus 5 equals 19. Negative 15 plus 9 is negative 6. The absolute value of negative 6 is 6. I think a lot of you can see where this is going now. 4 times 6 is 24. 24 minus 5. We end up with 19 equals 19 again. So this checks out. That is a solution. So in both our problems on the board, all of our solutions worked out. But again, you want to check these every problem just to make sure they both do work, because you're going to run into a lot of problems where both solutions won't work. So that's absolute value equations. Again, the big trick to absolute value equations is that you need to end up writing 2 equations from the original equation, and then you're going to solve both. So enjoy the practice problems and have an excellent day.